we're going to start the series here. The first thing that I'm going to do is open the folder that we just downloaded. And in particular, I'm going to open the detect.py. So we're going to be performing some imports first of the different libraries. Here we're importing PyTorch, critical piece. Here, basically, file, we have the file, detect.py, and the path. And then root, that's our YOLOv5 folder. Now root just become the relative path. So all different files, all different operations will be performed within the YOLOv5 folder. We're going to be performing some more imports here. Here we're importing the detect multi-backend, which is a big and very important class. Here we're importing the data loaders. Specifically, we use load images and some general utils, different functions, and the select device and smart inference mode. We're going to run this line here. Here we're setting the detection in inference mode. We're going to call the decorate function, and we'll set torch that inference mode to true. Our torch version is 2.2.2, so this will be applied. Otherwise, we'll apply the torch no grad. And now we're going to step over the run function. Here, I change it to YOLOv5L. The reason for that is within the Ultralytics website, the architecture that is shown is the YOLOv5L. And we're going to go through this architecture in more detail as we go through this series. So I thought it would be better to have that model loaded. The S version has different architecture, as you can imagine. It's a smaller version, and we wouldn't have such a nice representation of that one. So that is the main reason why we're calling the YOLOv5L. Here, we put our image, data, images, and we have our image. This is the image we're going to use to perform the predictions. This is 1024 by 768 pixels. Width and height is a color image, RGB, meaning that it has 3 channels of pixel data. Here it's going to read this, but the Coco 128, we can actually open it here. If I go data, Coco 128, if we were training, this would be the file that we will call datasets, and then the Coco dataset for training and for validation, and the different classes associated with it. The image, this is the size of the image that we want to feed into the neural network. As you saw, our image is larger, so the image will be compressed to 640 by 640 and 3 channels. And in our case, we're using the default 640 by 640 in order to keep the sizes consistent with this diagram, as well as the outputs, everything consistent. Our confidence threshold, that is the value above which we will consider predictions, is rather low, but we will keep it as default. Our predictions will be much higher. IO threshold of 0.45. This will be used for a function and an algorithm called non-max suppression, where if the overlap between different predictions is 45% or greater, then those predictions will be considered one prediction. It's just that different grids, as we'll talk about it later, will predict it, but then the grid with the highest confidence will be the winner. Non-max suppression, you're suppressing the ones that are non-maximum. We will limit the number of detections, keep this as default. In our case, we will not need such a high number. We will keep device empty for now. View image, this is to show the results right here on the screen with OpenCV, IMShow. We don't need that. We will have the image saved to disk. This is if we want to save the results to a TXT file or a CSV file, or save the confidence to a TXT file as well. This is to save the cropped bounding box. We'll keep that as false. The car class, which in the Coco YAML format that we're using the name structure. So in our case, class 2 is for the car. Agnostic non-max suppression, we'll keep that as false. Augment, we'll keep that as false. And then visualize, I'm going to change that to true. It was originally false by default, so that we can visualize the feature maps. Update all models, we'll keep that to false. We'll save results to runs detect. So basically, in runs, we'll have a folder named detect, and within that folder, another subfolder called X for experiment. Exist OK false. Basically, if we already have a folder called exp, then if we run it again, then create another folder called exp2, 3, and so forth. This is the line thickness of the bounding box in the output image. We want to see the labels. We want to see the confidence. We're going to use floating point 32. So we'll keep these to false. And these as well, since we're not using OpenCV's deep neural network module. We're only detecting a single image, but if we were doing a video or a streaming, then we will be analyzing, in this case, every frame, but we could be analyzing every other frame or every few frames as we desire. So when we run that, we've stepped over the run method, and we've gone all the way here at the bottom. Again, we just stepped over, and actually in the same way, we're going to step over this method, parseOpt, and then here, we're in the main method. We'll call the parseOut method. And in a similar fashion as we saw above, well, now we're creating a parser and different arguments. In this case, for example, we see that weights is the destination of the argument, and we have the value. Make sure you change this to YOLOv5 as well, since this will override the argument on the run method. So let's step over. Now source has this value, data/images. The image is the default 640 by 640. Confidence threshold. Here we're keeping the same default values that we had at the top. And then if we had a value like this one, this default value will override what we had on run. They both have false. If we don't have anything, then it will get the value from run. But if we have something, this value will override the run value. In this case, they're all the same. This has created an opt object right here with all the different arguments. When we run this, notice that the image size is 640. And this is saying that if the length is 1, which it is, make sure you make it two-dimensional. So in this case, the image size will become 640 by 640. When I run this function, we're going to print here in the terminal the different arguments, showing detect, and we're showing the different values here. We return opt, which is then fed into main, which is right here at the top. Main checks the requirements, and these are the different Python libraries and packages that we already installed. Now we feed all those variables from opt into the run method that was defined at the top. So we're going to go all the way to the top.